Slides are visible to you? Hello? Am I audible? Okay. Slides are visible to you, right? Yeah. Is it visible, right? Yeah. Yeah. So, very good evening to everyone. Myself, Swapnil Valasaheb Godke, and currently I'm doing my doctorate at the Indian Institute of Technology, Roorkee. So, I will be the session and teaching assistant for this session, working under the Professor Sudhir Mishra, sir. So, first of all, I hope you all are going through all the lectures, and maybe some of them also calculated also. So, first of all, we'll see the recap of the week one lectures. So, basically, what are the general constituents of normal concrete? So, normal concrete uh, is a like non-homogeneous. Concrete is a non-homogeneous material and very complex material. So, it requires very flowable in the fresh state, and it requires to be hardened after some time to get the sufficient strength. So, cement is the primary binder materials we are using. Then water is the solvent. Then as an inert material, we are using fine aggregate and coarse aggregates. As you see in the lectures also, cement paste is a basically mixture of the cement and the water. So what we can say, cement paste is a suspension of cement in a water. And if we added fine aggregate in that one, what happens? It become a mortar. So we can say sand or fine aggregate, it will be a suspended particles in the paste, which is a mixture of the cement and the water. Next, if we added the concrete coarse aggregate, what will it will become a concrete. So if it becomes a concrete, what we can say, concrete is a suspension of coarse aggregates in a mortar. So basically, it is a very complex and composite material. So based on this primary understanding, we understand that there are two phases in the concrete. One is the mortar, and another one is coarse aggregate. And we can consider, suppose this image you can see, there is a series of the materials, and this is the parallel materials. Series means mortar and then coarse aggregate one above each other, and it is in a parallel condition, mortar plus coarse aggregate. But in the actual casting process or in the actual concrete, the existence in between this one, it will not be exactly series and it will not be in exactly parallel condition. Why it matters, we'll see in the slides. One another phase will come into picture. That will be the interfacial transition zone. What is interfacial transition zone? Basically, what happens? Coarse aggregate will be there, and we have two phases: mortar and coarse aggregate. So, what happens when we are casting the concrete? The amount of the water into the concrete will bleed towards surrounding the aggregate, and because of that one, higher amount of water content will available surrounding the coarse aggregate. So, because of that. One separate layer will form surrounding the aggregate. It's not necessarily that layer should be the uniform in surrounding the aggregate. But what happens because of the higher amount of the water content? Uh, can anyone tell me what happens if the concrete has the higher amount of water content? Bleeding will occur. And what happens with the strength? Yeah, strength decreases. So same thing happen in the ITZ also. Because of the bleeding, yes, yes, yes. Yeah, it's just for the understanding we are getting how load will suppose load we are applying, how it will behave, we'll understand in the upcoming slides. That's why we are only considering the series and parallel, but in the actual condition it will not be in exactly in the series or parallel, it will in between that one. Because Yes, yes, yes. Simply for the analysis, for the better basic understanding only. So, as you said, like if water is the more, the strength will get decreased. So, as I said, the water will come surrounding the aggregate, so higher water because of the bleeding of the concrete, and that higher amount of water will create the less strength of that surrounding the aggregate. If you see this image, this is the aggregate, this is the mortar. This strength of the mortar and the strength surrounding the layer having that coarse aggregate will differ. That is called, that's why three phases coming, that is interfacial transition zone. So it is having the higher cement water to cement ratio, nominal thickness around the aggregates, but need not to be perform similar around the or uniform around the aggregates. Why interfacial transition zone is important? Because it affects strength also, crack propagation, stress strain curve, and permeability. So how it affects strength? Maybe you have gone through previously in the bachelor's or the master's through the IS code. So we have normal concrete and high strength concrete, right? So how we'll identify normal concrete and high strength concrete? Anyone, please? Okay. Uh, yeah. Grading is the one of the major aspect. But if we want to classify it according to the water cement ratio and the failure pattern, then yeah, maybe like ultra high performance concrete. But what happens if we consider normal concrete, not ultra high performance concrete, which has the higher cement content, but normal concrete also has a little bit higher content. But thing is that in the normal concrete and the high strength concrete, high strength concrete will have a less water to cement ratio. As we, if you want to classify it according to the water cement ratio, it will have the less water to cement ratio. And if you want to classify it according to the failure pattern, if you go with the compression, what happens? This because of the compression, crack will occurs. But this interfacial transition zone will allow to happen the crack in first. It will allow the happening of the crack firstly, and then lateral matrix will happen with the cracks. So what happens when we are going with the compression? Normal concrete, the crack will happen surrounding the aggregate. This aggregate is there, so crack will happen surrounding the aggregate. But in the high strength concrete, the mortar is very strong, and similarly, TZ is also strong as compared to the normal concrete. So in that case, what happens? The crack will occur through the aggregate. Aggregate will broken down. So if we are having the two samples of the crushing compression strength already occur, one is having the aggregate which is a crack happening surrounding the aggregate, and another one is having the aggregate is broken down. So we can easily identify and say that wherever the aggregate is broken down, that is the high strength concrete with the visual inspection itself. And another is like basic based upon the mixed proportion, that is less water to cement ratio. Can anyone tell me if like we have the water cement ratio zero point 0.5 and if we have the water cement ratio zero point 0.3, still we will say like zero point 0.3 water cement ratio giving high strength. Why it happens? Because water required for the hydration, right? Yeah, please tell me. Right, right. That helps to reduce the cement content as well as that helps to maintain the same flowability, right? Yeah. But thing is that a certain amount of cement is there. You are saying cement content is also reduced, but still certain amount of water. Suppose at least zero point 0.4 amount, zero point 0.4 water cement ratio is required to get the fully hydrated cement, and we are providing zero point 0.3. So to get the higher strength of concrete. So how will achieve high strength? Still, whole cement is not hydrating. Hmm. Right. Hmm. Hmm. Yeah, it's sufficient, no doubt, because it's giving high strength as we're seeing the high strength concrete because of the less water cement ratio. But what happens, whatever the extra cement is available apart from the hydrated cement, that cement will act as a filler. And because of the filler, whatever the pores will be there, that pores will get filled. And because of that one, the strength, what is the strength dependent on? Large amount of pores means strength will get reduced. Less amount of pores, strength will be high. So that will act as a fillers. And for the curing, lateral strength will increase because of the extra water we are adding with the curing. And whatever the available water which should not get evaporated through the specimen. Okay. Yes. Yeah. Not actually. Thing is that it will not. As you said, super plasticizer we are using already. Cement content is less than the normal concrete. But whatever will be the extra cement available, which will not get the hydrated, that unhydrated cement will act as a filler. That quantity will be less, but that will act as a filler. Yeah, yeah. But already we are reducing with the super plasticizer. It will not be that much high. Sometimes, like concrete, like ultra high performance concrete, we are using filler as a quartz powder. So, which will as an inert material, which will not react with the water like binding material, which will only fill the whatever the gap or voids between the gradation. Okay. As a quartz powder. Quartz powder will be costly, and the ultra high performance concrete is also very costly as compared to the normal concrete. Super plasticizer, it's not that much costly. If you see any type of admixtures at this moment, it will, because thing is like that we are not using in too much quantity. We are using only the 0.5 to 1% of the binder content. Uh, so, so ultra high. Yeah, UHPC is costly because that is having the higher amount of cement consumption than that silica fume. Because silica fume is very costly. It's as I know, it's around 27 rupees per kg. It like that, so it will be very costly. And yeah, people are using GGBS also, but as the coarse aggregates are not using UHPC, all the binding material quantity is very high. Because in the normal concrete we are having the 60 to 70% of the coarse aggregates. Yeah, so that's why that compensation will happen in that way. So as we say, series model and parallel model. So we are applying the load. Suppose we are having two models and we are applying on compression load. So what happens, you see in the first image, mortar and coarse aggregate, and the middle phase is interfacial transition zone. In this case, interfacial transition zone will not be the critical part because it will not come directly load over that bonding. But in the case of the parallel, you see the load is coming directly on the onto the bonding part. So that will be the critical. Why? But in this case, the stresses will be the stresses will be the differ, but strain will be the what will happen in the series and course aggregate stresses and strain. We Yeah, crack will happen is very initially in the interfacial transition zone itself. Yeah, it is there because that is the weakest part of the concrete specimen. But I am saying we already saw in the strength of material parallel phases and that series phases, what happens in the stresses and strains? In the series, stress will be the similar in the mortar or coarse aggregate or different, right? And strain will be differ because of the change in the elastic modulus, right? Yeah, and so here strain compatibility will happen because of the this bonding will try to maintain the same deformation. So that's why strain compatibility, and that's why first of all, if it is not able to maintain the strain compatibility, crack will appear easily on the interfacial transition zone. So ITZ and permeability of concrete, there is a direct relation between that one because of the higher amount of water into the interfacial transition zone. That some amount of water will get evaporate and will create the voids or pores. Mm, yeah, yeah. Yeah, thing is like that coarse aggregate are very stiffer compared to the mortar, right? So it will not deform easily. So mortar will deforms. Yeah, right, right. Yeah. Here also, here why here similar? It try to be similar because interfacial transition zone that bond will maintain to get the similar deformation. Yeah, that fails means 1 second. Someone has joined. Yeah, yeah, please. That tries to fail easily. When it fails, then there will be no strain compatibility. That's why it is a critical part. Yeah. And why ITZ and permeability have direct contact, direct relation because of the high amount of the voids creation. Because of the high amount of water, it will get evaporate. Some amount of water will create the voids. And suppose we have the voids in the concrete. There is a basic difference between the pores and permeability. Do you know that one? It's not like that. Actually, what happens? Pores. Yeah, yeah. Tell me. It will be proportional to the not pores. It will be the interconnected pores. Yeah, the pores should be the interconnected. Then will be the permeability happen. If the pores will not be interconnected, permeability will not happen. But there is a possibility to get the some outer part of the hazardous material into the concrete and will affect its durability. So permeability is more about the interconnected pores, and simply pores or voids will happen or reduce the strength of the concrete. Mm, mm. Yeah, yeah, yeah. Thing happens like what? Suppose we go for the parallel model. It's the weakest part is ITZ. So first crack appear in the ITZ. Then suppose we are going to increase further load, then will happen into the mortar and then some part of surrounding the coarse aggregate or like that, but not exactly through the coarse aggregate. So around the coarse aggregate will happen, but through the coarse aggregate in the high strength concrete. Clear? So so we'll see first of all the basic fresh properties of the concrete. So concrete should be workable. So why it should be workable and it should have a sufficient amount of the initial setting time? Because if we cast the concrete, we should have a sufficient time to pour into the suppose we are preparing the beam or we are casting the beam or column. We should have the sufficient time to pour into that cast specimen, and we'll get the proper compaction also. But sometimes we require the flowable concrete, sometimes we require the stiff concrete also. So there are different types of equipment available to identify their workability based on their behavior. So suppose for the steep mix, we will use the wave time. Then normal concrete, we will use the compaction factor and slump. And flowable concrete, will use the slump flow. I hope most of the equipments we already have used in the bachelor's. So what happens, like in the digitization of the concrete nowadays, for the 3D printing concrete, like you can see people are using the floatable test, which will be the most more easy and more appropriate for the 3D printable concrete, which will not be exactly the stiff, which will not be exactly the flowable concrete. So according to their behavior, different types of the equipments we are using. And air entrainment. So different types of admixtures are available, like water reducing admixtures are there, then accelerators are there, viscosity modifying agents are there, and according to the requirement of the concrete or casting procedure, we have to use that one. But sometimes we have to consider the air entrainment also. Anyone knows where we have to use air entrainment as admixture? Right, cold weather conditions, yeah. Yeah. So like cold weather countries are there like Canada and some Norway or something like that, wherever we have to use the air entrainment. Why we are using the air entrainment? What is the purpose of using the air entrainment? Right, right, right. So what happens? We already casted the concrete. Some amount of water is available still in the concrete in the hydration phases. So what happens when the temperature goes to like below 0 degree Celsius or minus, so that whatever the liquid water available, it will get solidified or frozen. So frozen water has a higher volume than the liquid. So that water will try to occupy the space between the concrete, but there is a no space. So because of the less space, the cracking will happen around the concrete. So to avoid that one, we'll already create some bubbles in the form of the air entrainment will provide. So because of that one, that whatever the water will be available, that will get some amount of extra space, and there is a reduction of the cracking will happen, or there is a no that much possibility to happen the cracks. But in the case of the normal concrete design, we will consider the 1 to 2% of the air entrainment. In the case of the design of the normal concrete, we are doing the mixed design. We'll consider the 1 to 2% of the air entrainment. But in the design of the like cold weather concreting, we'll consider maximum of 4 to 6%. If you go beyond that one, further it will reduce the durability because of the increasing the pores and interconnected pores. So that's why it has the maximum amount is of 4 to 6%. Hmm. Actually, this value we are not adding. We are just considering into the design because of the while we are casting the concrete, there has a certain amount of air entrap happen, right? So that only we are considering. We are not adding externally, and that value has given by the Indian standard codes based on the trial and error. So yeah. Mhm. Yeah. Yeah, right, right. It is like for normal concrete, they has given 1 to 2%. It's not about the slump because the self-compacting concrete itself, there is no need of getting to compact itself. So maybe it will have less amount of air in trap. So basically, what fresh concrete should have adequate workability to get the workable in the proper conditions. Hardened shed should have adequate strength. Durability, there are certain amount of certain Indian standard provisions are there. How much amount of water content we have to consider, and how much amount of higher amount of cement we can consider. Beyond that one, we should not go. That conditions are there in Indian standard codes for the durability aspects. And temperature rise during setting. So where we'll find out the temperature rise will be the one of the major problem. Which type of concreting? Uh, Not exactly high strength concrete. It will be regarding to the mass concreting. So what happens? Mass concreting. Suppose we are constructing the dam. So there is a huge amount of width and huge amount of the length will be there. While casting that one, what happens? The temperature difference are on the surface and the temperature difference around the core. If it is a much, there is a possibility of this temperature difference because of the thermal cracks will happen. So that's why. What? Yeah, water coolings are there. Like yeah, I also visited one of the chilling plant. They will say they have chilling plant. So most of the big construction companies, they will use the chilling plant to use the cold water to avoid the higher amount of the heat generation. And because of that one, the cracks will not appear on the surface or on the core. So further, what are the hardened properties of the concrete? Yeah. At this moment, I did not recall. I have to see. Yeah. Maybe in the next lecture, I will tell about that one. So, what are the Hardham properties? So, Hardham properties basically more important is characteristic compressive strength. We are more heard about the characteristic compressive strength, the tensile or flexural strength, modulus of elasticity, stress strain curve, shrinkage and creep, permeability and durability. So everyone is aware about this graph. We are seeing since our bachelor's. This is the characteristic strength graph distribution. So main strength is there 1.65 into standard deviation. This is the characteristic strength where 5% of the test results should fall below that one, should fail. And this is the FCK characteristic strength, and this is the mean strength. So as I said, water cement ratio goes on increasing, strength goes on decreasing. So there is a direct relation between the water cement ratio and compressive strength. So for to find out the water cement ratio, we are using the target mean strength. Which is the target mean strength? This one. In the case of the design of concrete mix, we are using the target mean strength. But in the case of the quality control and acceptance, we are using the characteristic mean strength. So suppose we are giving the design, we are designing the concrete mix, and we are saying M10, we are M15, M20, M25, M35. So what it indicates? 35, what it indicates? Yeah, right. It is the characteristic strength. So it is that's why we are considering for the quality control and acceptance, and we are saying that is the characteristic strength. And we are suppose we are testing a three cubes, and we'll get the average of the three cubes. So, what will be the basic criteria? Suppose we are tested for the M20, and we are get the three cube strength. Average strength is around. Suppose we are getting 20. Sorry, 19. We are getting. So, how we'll say this value is correct? Whatever the average we are getting, it's correct. we will have some checks based on the Indian standard code, right? Yeah. So what we'll do, whatever the average we are getting, suppose we are getting the 19 average, and whatever the individual strengths we have, we'll find out plus or minus 15% difference should not be there. According to the 15.4 clause in the Indian Standard Code, the individual variations should not be more than plus or minus 15% of the average, right? Or we are also more aware about this situation while testing, or most probably we are using 3 cube specimens only labs. So we'll check this one only, plus or minus 15% of the average for the individual cubes. But what happens? Why we are using only 3 cubes? Because code has given some guidelines. So based on the quantity of concrete in the work in meter cube. So if 1 to 5 meter cube concrete we are concrete use casting, the number of samples code says one should be sufficient. For 6 to 15, 2, 16 to 30, 3, 31 to 50, 4, and 51 and above, 4 plus 1 additional sample for each additional 50 meter cube or part thereof. So, but in, yeah, 1 day work. Because what happens, most of the like big, like as I said, dam, they are using continuous ready mix concreting continuously, but that's depend upon the batch of the concrete also, because what happens, wherever the specimens you have to collect, that is also important. Suppose one ready mix batch is coming, you will collect some samples from there, some other coming your, or you can collect all the samples from the one batch. That is also important. So that is quality control is based on the some of the experience of that quality control engineer also. So but it's very important because once again, batch to batch also, concrete also varies. So it is here is also it's given note. At least one sample shall be taken from each shift where concrete is produced at a continuous production unit, such as ready-mix concrete plant. Frequency of sampling may be agreed upon mutually by suppliers and purchasers. So code also says the same thing. Yeah, right. Yeah. 31 to 4, 50. 31 to 50, 4 samples, and above the 50, 4 plus 1 for each 50 or part of thereof. Hmm. Yeah, 5. Yeah. Suppose we are going for the, yeah, right. Yeah. But in this case, what will be the like acceptance criteria will be difference. That we'll see. So, and suppose we are going for the 120 meter cube, that time 6 sample will come into picture, right? Okay. So, what code says, for concrete of quantity up to 30 meter cube, where the number of samples to be taken is less than 4, as per the frequency of sampling given in 15.2.2. The mean of the test results of such samples shall be FCK plus 4 MPa. What it means, suppose less than 4 samples means 3 samples we are taking. The mean of the test result should be minimum FCK plus 4. FCK which one? Suppose we are mix designing the concrete for 20 MPa. So 20 plus 4, and minimum, and the requirement of minimum individual strength 20 minus 2, 18. Hmm. And however, when the number of sample is only 1, that time requirement shall be FCK plus 4. But what happens if you are going for the 4 samples? So that also given by code in the table 11. So what code says, if you are going for the 4 non-overlapping consecutive samples, that time for the M15, This is M15. It should be greater than FCK plus 0.825 into standard deviation, or FCK plus 3, FCK plus 3, whichever is greater. So what happens? We sometimes it's very difficult to have the standard deviation at the site. So that's why code also given some standard deviation values based on their grade of concrete. For M10 to M15, we can use the standard deviation value 3.5. And suppose we are casting the concrete M15 and 15 plus 0.825 into 3.5. Whatever the value will get it, and the FCK plus 3. So whichever is greater, that one only we have to consider for the acceptance criteria. For individual, it should be greater than FCK, and M20 or above, the value FCK plus 0.825 into standard deviation is there. Just we have changed FCK plus 4 here. Here it's FCK plus 3 up to M15, and it's FCK plus 4. So whichever is greater out of that two, we have to consider. And anyone tell me for the to plot the characteristic strength graph or standard deviation, how many samples we have to test it? Right, 30. But sometimes it's not possible to find out the standard deviation with the testing the 30 samples. So that's why code has given some approximate values. For M20 to 25, it's given 4. M30 to 30, 50, it's given 5. And the note has also given here. In the absence of established value of the standard deviation, the value given in table 8 can be used or can be assumed. Okay. So this is the, yeah, it's not exactly mentioned in the code, but you'll find out some literatures based on their like researchers experience only. But code has not given for the 7 days, it has given for only 28 days, because we are considering almost most of the strength we will achieve within the 28 days. So that's why code has given for 28 days only. So this is the basic part, all I have covered from the lectures only. Once you go through the lectures, you will get the better understanding of this topic. Okay. So we'll see some of the questions from the previous year's lectures. So we'll get through answers through your interaction also. And based on this type of questions only, you can easily solve your assignment also. So the first question is that in the context of the interfacial transition zone, consider the following statements. So statement one, formation of the ITZ around coarse aggregate in concrete is a manifestation of bleeding in concrete. And statement 2, paste in the ITZ is characterized by a slightly lower water cement ratio than the paste elsewhere. So what will be the answer? Statement 1 is what? Correct or wrong? Okay, and 2, okay. All are saying false only. Any other answer? Correct. Statement 1 is true and 2 is false. We already saw the water cement ratio is higher surrounding the aggregate, that is in the ITZ zone. And why it is happened? Because of the bleeding in concrete near the aggregate. So one is true and second is false. So we'll see a little bit explanation about that one. So why? So as I said, it will not be uniform, but it is very like complex situation to find out the exact width surrounding the aggregate, whatever the ITZ have. So for that purpose, approximately 50 micrometer thick we have to we will be considering that one. Okay. So if you get any questions regarding that one, what will be the thickness of the ITZ? Maybe it's correct that it will not be uniform, but we are considering approximately it should have a thickness of 50 micrometer. It may be more than that one, it may be less than that one, depending on the situation of the concrete or hydration of the concrete, right? So if you see, this is the same image of the ITZ section, that is scanning electron microscopy image. You can see this is the aggregate, this is the aggregate, and this is the interfacial transition zone up to this one, and this is the bulk zone, and this is the legends of that that's calcium silicate hydrate, calcium hydroxide, and calcium aluminum silicate hydrate, which is called as yttringite, which will form initial phases of the hydration process and responsible for the earliest strength of the concrete. If you see in the interfacial transition zone, you can find out CSH amount is very less, which will be more major component of the strength or binding component, calcium silicate hydrate, which is less. Apart from that, calcium hydroxide and CSH part is more. So because of that one only, CSH is high amount here. CSH, calcium silicate hydrate, is higher here and lower here. That's why this part is more weakened. And this is the exact picture taken from the scanning electron microscope or schematic picture it has been given actually. So that also mentioned written here same compared to the bulk paste. This is the bulk paste. Other matrix. ITZ has less unhydrated cement, less CSH, large crystals of calcium hydroxide, and greater concentration of yttringite, that is CSH, and higher porosity. So because of that higher porosity, it has the less strength and weaken the structure in that part and responsible for the earliest cracking. Sorry, first crack appears in that region only after going after the sample is going through the compression. So what we have to, yeah, because what happens, the bleeding will happen. So bleeding, what is the meaning of the bleeding? So bleeding means whatever the water will come up and whatever the higher particles will go down, right? So higher particle cement is also in that particle will go down. So because of that one here, CSH part will not be that one, because of the hydration will not happen that much, hydration will happen here only. So here CSH part will be less because of the only water quantity is more compared to the cement. Yeah, right. Hmm. Okay. That even I have to see in the detail. Okay. So basically what we have to remember, what is the part of the ITZ, why ITZ happens, and it has the weakest part of the structure or the concrete, and thickness, mainly thickness you have to consider approximately 50 micrometer. Okay. Any other doubt? Okay, we'll go for the next question then. So, in the context of the aggregate used in concrete, consider the following statements. So, statement one is the rounded aggregates are preferred from the standpoint of workability. Flat and elongated aggregates are preferred from the standpoint of strength. So, what will be the correct option? Second, one is true and statement two is false. So, can anyone tell me why it happens? Rounded aggregate gives more workability and flat and elongated aggregates will not give, right? And what is the right? What is the reason of the second one? It's wrong. Why? We'll see that one. What happens in the case of the rounded aggregates? So rounded particles have the lowest surface area to volume ratio, and we also have the minimum voids 30 to 33%. So this reduces the internal friction and have the more lubricated effect. And requires because of the less surface area to volume ratio, we require less amount of paste to lubricate the surface. So because of that one, we will have the better flow and workability in the less mortar content itself. Okay, but in the case of the flaky and elongated aggregates, these aggregates are weak because they break easily, reduce the workability, and lead to poor packing. Main thing is that poor packing. The strength comes from the packing and the calcium silicate hydrates binding any type of the concrete. So what happens if it is not properly packed or dense packed? The strength will be less. That's why second option is wrong. So which type of aggregates gives the more dense packing? That angular or cubical aggregates. That will, yeah, that will give the more better interlocking and minimum void ratio. So that's why better interlocking will have the higher dense structure and will have the higher strength resistance. Will get the more strength compared to the elongated aggregate. Okay, so that's why second is wrong and first one is the correct one. The next question is that two batches, suppose A batch and B batch concretes we are designing, and FCK is, and characteristic strength is FCK. And we have the characteristic strength for A is 60 MPa, B is 30 MPa respectively. So can you tell me please what is the ratio of the EA upon EB, that is elastic modulus ratio, for the A concrete and the B concrete? We have the characteristic strength. According to the IS code, we have formula. Anyone knows? Right. So 5000 root FCK. So what will be the ratio of the EA by EB? Yes, please. 2. Option 3 you are saying, right? Hmm. Option 3. Any other? It will be root 2. We have formula 5000 into under root of FCK, right? So 5000 into under root of 60 for EA, 5000 under root of 30 for EB, and ratio will come into EA by EB. 5000 get cancelled, under root of 60 by 30. So it will come into EA by EB root 2. Yeah, you missed the root, it seems. Yeah. So answer will be the root 2. So this is the formula given by the IS code. So if you know the characteristic strength, we can easily identify the modulus of elasticity based on this formula. So next question is, in the context of measurement of workability of concrete, consider the following statements. So VB time increases as the workability of concrete increases. And slump flow is useful method to measure the workability of highly flowable or highly workable concrete. So which statement are true or false? Both are false. Okay. Any other answer? Two is right. Okay. One is false, two is true, right? You are saying, right? Okay. Third option. Right. So slump flow. Everyone know about the slump test, right? Everyone aware about the slump test. Yeah. So slump flow is what happens. We'll use the similar method, but we'll measure the flowability of the concrete on the platform. We'll see how. And VB time is the increases as the workability of concrete increases is wrong, because as the VB time increases means workability of concrete is less, because yeah, we'll see the test. You'll see this explanation. This is the VB test according to the code. So what happens? We'll have the slump. We'll put into that one. We'll and measure the. We'll vibrate that table and we'll measure the time. So this cap the apparatus fully covered by the concrete grout. So under that vibration, this concrete will get flat, and we'll measure that time, how much time it requires. So that's why when concrete is very stiff, you'll see the slump is zero. So that's why we are using vibration. And because of the vibration, we are measuring their workability, because we require to measure the workability of the stiff concrete also. So that's why we are providing external force as a vibration. And the higher VB time indicates lower workability, more stiffer mix, and while lower time indicates higher workability. And in the case of the slump flow, what happens? Similar to the slump cone, we have the Abraham's cone. We just pour the concrete in that one. We lift it up and we'll measure up to 500 diameter. To that, how much time will required. So based on that one, we'll find out the flow of the slump flow of the workable concrete, or more highly flowable concrete. In the case of the slump flow or the self-compacting concrete, we are using this test majorly. So self-compacting concrete, this is the one of the major test we are using, that is slump flow. Another one is yellow box test we are using, and J-ring test also we are using. So three three to four types of tests we are using the self-compacting concrete to measure the flowability. They're only not only the part of the measure the flowability or workability. Workability considers their flowability, passing ability. So why we require passing ability in the self-compacting concrete case? Right, right. So if it is have the good passing ability through the L box test or J-ring test, we can consider that self-compacting concrete will pass through the rebars easily and will not require any external compaction. So that's why two different tests under the workability will fill the two different purposes. One is the flow through the slump flow, and another one is the passing ability through the J-ring and L box test. So that is not in the cover in this lecture. So that's why I am not discuss their uh, explanation in this one. Any other doubt? Okay. Then we'll go for the next question. So following figure shows the cross section of a concrete cylinder loaded along the diameter. The nature of the stress points at A and B. So this is the cylinder. Suppose it's cylinder going under the splitting tensile strength. So splitting tensile strength, So we have we casted the cylinder which have the aspect ratio of 2, means suppose length is 300 mm, we have the diameter of 150 mm. So aspect ratio of 2 we casted, and we go for the compression, that is splitting tensile strength. So concrete will split. So what happens, these 2 points A and B? So what will tell this A point and what will tell this B point? Where will be the compression, where will be the tension happen? What you understand from the figure and based on your visual inspection? They will be in tension. Okay. Air compression. Any other? All are agree with this answer, right? So tension at B and compression at small area around the A, right? So why it happens? What happens? To ensure the equilibrium of the section, the section should be in equilibrium. So tensile stress at the point B, the tensile stress at point B balanced by the compressive stress at regions, that small area surrounding the A point. And that's why A is in compression and B is in tension. And we are also like visual inspection also we can consider that. Suppose we are pressing something below, suppose we are pressing something with our hand only, below the hand or touching with the hand only, we'll get some compression, right? And suppose we are pressing rubber itself, middle part will go into the tension. So that is the basic understanding of this one. So answer will be 3, tensile at B and compressive at in a small area around A. So next question is, in the context of producing fiber reinforced concrete and roller compacted concrete, consider the following statements. The statement 1 indicates in fiber reinforced concrete, adding fibers leads to increase in water demand in the concrete for the same workability of concrete. And statement 2, in the roller compacted concrete, the proportion of coarse aggregates are much lower compared to the coarse aggregate content in normal concrete. Okay. Any other? Hmm. What about 2? Hello. Both are true. Okay. So answers are differ here, right? So who has said first one is correct and second one is wrong? The answer is that one only. Yeah, second one is right. So why? What happens because of the addition of the fibers? Suppose we are adding some natural fibers, like bio-based fibers or something like that. That will absorb some amount of water. But if we are using some like steel fibers, like that thing, that happens because of the adding of the fibers, that agglomeration will happen. So to get the more flowability, we require the extra amount of water. And in the case of the roller compacted concrete, the binder content will be the less. So coarse aggregate content we required higher to bear the weight coming from the roller and to get the more compacted platform in the roller compacted. So that, as I said, for the natural fibers, we required that higher amount of absorption of water. And in the case of the other fibers, high surface area absorption capacity in the case of natural fibers only requires higher water content to maintain the workability. If you see some amount of like we have the uh, flowable concrete and we added some fibers in that one and mix it and you'll see whatever the flow you are getting, that flow will get reduced. To maintain the same flow, we further add to get the water more amount required, or the we have to add the super plasticizer also. Yeah, according to the some literatures, it is found that 10% of the reduction in the strength will happen. Most probably, the fibers will be useful for the tensile strength only, not the compression. So that's why reduces the, yeah, yeah. But in the case of their more effect will observe in the case of the tensile strength only. So when you are going for the flexural strength or whatever the your beam going under the flexure, so the cracks will occur less, and because of the fibers, that bridging will happen. The widening of the crack will not happen. So that's why tensile capacity goes on increasing. Suppose you see most of the UHPC or most of the 3D printed concretes, wherever in the case of 3D printed concrete, rebars are not used steel. So that purpose is only they are adding the fibers to get the some tensile strength. So more use in the tensile strength only, and the compressive strength observed 10% of reduction as per the literature. And in the case of the roller compacted concrete, typically contains higher total aggregate content, 70 to 85% by volume. Normal conventional concrete we have 60 to 75% only, and the roller compacted concrete have more than that one. That is 75 to 85% on only 25 to 15% binders. So that's why second answer is wrong. Second statement is wrong, and first one is correct. Okay. So next question is that we have three identical concrete cubes with the same concrete mix. And what happens? We are going for the compression failure test. So what we do, rate of loading, we kept it different for each cube. Suppose for A, the rate of loading is smaller than the B, and B having this rate of loading smaller than the C. Means C is the highest loading rate, middle is B, and A is less. So what will be the strength observation we'll get it? Does we have any direct relation of the rate of loading with the strength? Can you repeat, please? Yes, we have relation. So what will be the answer? C would be having the maximum strength. So which will be the option? Second. Okay. Okay. Any other? Yeah. Okay. Any other? The answer is correct. So why it is happening? Anyone have any idea? Hmm? Hmm. Yeah. Yeah. That is the main thing. But what is the mechanism behind that one? Why it happens? Hmm. No, as I in the first sentence it has mentioned the same concrete mix is there. Only we are changing the rate of loading. So there must be some relation because of the rate of loading. Something will happen, some mechanism will happen. So because of that one only, strength differs. Suppose we go with the same rate of loading, strength will come nearby same. But we are going with the different rate of loading because it's as the same concrete, we are getting the different strength. So there must be some reason behind that one. So what happens? Why higher loading rate leads to higher strength? At lower or slower loading speeds, the material has a more time to deform and allowing for a crack propagation and lower resistance. So that's why we are getting lower strength in that condition. And that's why rate of loading is very important part in the testing of the compression as well as the flexure also. So what IS 516-1959 says, specific loading rate, it should be 140 kilogram per centimeter square per minute in Indian conditions according to the IS code. So low at slower loading, we'll get the cube A will get the more time to deform, then allowing for the crack propagation, and lower resistance is has given to the that loading rate. So because of the lower resistance, we'll get the lower strength. Higher resistance will get the higher strength. For the higher loading rate, the concrete or that cube will not get more time to rearrange or deform. It will give the direct exact strength. Okay. So next question is, in the context of bleeding in fresh concrete, consider the following statements. Excessive bleeding decreases the water cement ratio in the top surface of the concrete. And statement 2 is, bleeding is the result of settlement of heavier particles, including the cement and sand particles in water. Right? Mhm. Okay, right. Statement 2 is correct. Anyone have any other opinion? So answer is correct. Statement 3. And so because of that bleeding, we saw that less amount of CSH in that zone only also. Right? Heavier particles will settle, including sand. And bleeding means excessive water cement ratio. So statement 1 is automatically wrong. We can easily identify that one. It's not. It's very difficult. Suppose we are going for the large constructions, it's very difficult to remove the. But you can control the compaction frequency or a compaction period. Suppose we compact more. Suppose compact more amount of water will come into the surface. So we, based on the experience, we have to identify like optimum compaction, and some amount of water still will come, but we can avoid more amount of water. Right, 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 right. Uh, that uh, that being compensated is very difficult, but curing it's the most like acceptable way. Proper curing, you are providing the external water for the hydration. No, it will not depend on the pores of that concrete. It will not penetrate, but some amount of strength will lose in that way, like through the bleeding also. Because of more amount of hydration will not happen. Maybe that unhydrated cement will act as a filler only. Mm. Yeah, that will help. But if you that will help because water and strength has the direct relation. If you are reducing the water cement ratio, the strength will get increased. But at the same time, you have to maintain the same flowability. So you have to add the admixtures. And suppose for one project you required M20 concrete, and for that purpose you required a zero point 0.4 water cement ratio, but you are using a zero point 0.3, so you'll get the high strength of concrete, obviously, but there is not requirement of that one. Then you have to think about that one. That high strength is not required. Hmm. Uh, I don't think so because thing is like that bleeding is depend on the like casting out the concrete, how the procedure you are adopting. Suppose you are putting concrete from the higher altitude, that time also bleeding will happen. So higher amount of compaction, that will time also that more amount of water will come into the surface. It's not directly related with the super plasticizer. No doubt you are reducing the water content, but still you are reducing the water content, and still you are going with the higher compaction, or pouring the concrete from the higher place. There is a still possibility to get the whatever the water available come into this top surface. So proper execution is more important. Okay. Yes. Right. Hmm. Yeah. Okay. As huh, actually, I'm not much aware about the RMC plants, but thing is that whatever the limited knowledge I have, uh, that according to that one, they initially only mix with the little amount of water, and whatever the water cement ratio, other water in between the mixer will move. So yeah, continuously rotating. So continuously little bit amount of water they are adding, whatever that I read somewhere is like that only, but it's not detailed knowledge I have about that one. Hmm. Okay. Hmm. Yeah, it should not be. It should not be the practice because ultimately you are increasing water, you are reducing the strength. Hmm. 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 Yeah, you're right. Can you repeat again? Yeah, obviously you're. Yeah, because it's increasing the water content means water cement ratio will also increase. Yeah, but that will affect your concrete quality. That should not be the good practice. It seems. Yes, yes. Yeah, that. Yeah, but I think Professor Mishra sir will give better answer than me for this one. You can ask in the forum also, or you can maybe mail him. Okay, thank you. Okay, so next question is that given the characteristic compressive strength FCK, the target mean strength of concrete in Indian codes and guidelines may be calculated using the equation. What will be the equation of the target mean strength? I think everyone is aware about this equation, right? Standard deviation. But FCK plus, but we don't have an option here. So option answer will be the none of the above. Okay. So next question is which of the following best defines the creep in concrete? So increasing strength of the concrete over time on account of curing, increasing deformation of concrete over time at constant load, the initial increase and then decrease in temperature of concrete on account of heat of hydration, or last, dimensional changes in concrete over time on account of shrinkage. So what will be the creep? Second one. Yeah. So everyone is agree with that one? Yeah. So increasing deformation of concrete over time at constant load means sustained load. So can anyone tell me? Suppose we have the column, right? We casted the column, and then all the columns we have casted, and we casted the slabs also. So what happens? Certain amount of deformation will happen into the column, right? And the deformation with respect, who is the responsible for that deformation? Aggregate or paste or mortar? Column is there, certain amount of deformation due to the creep or certain amount of load happens. So what will be the responsible for that initial deformation? Concrete, sorry, coarse aggregate or paste content, right? Mortar. Yeah, paste or mortar. Because thing is that coarse aggregates are very stiff and it's not responsible for the deformation at all. So thing is that paste undergoes deformation upon sustained loading, and creep of concrete is a continuous process, varies with the age. At early ages it happens in the more, and the latter ages it goes on decreasing also. With increasing age, the creep also goes on decreasing because of the decreasing the deformation. So how it behaves, this image is from the macrogranite books. So what he indicates, you see, time after loading days. Initially we casted, then we suppose we casted the column and we put the slabs in that one. So initially we get the sudden change in the deformation that is called the elastic strain. And with age we'll get some creep strain. Creep strain will get, suppose certain amount of time we remove that load, whatever the sustain load we are giving, we remove that load. So what happens? Certain amount of elastic recovery will also happen, and that after that elastic recovery, certain amount of recovery with a sustained period of time. It will not, elastic strain will happen at the same time, and elastic recovery also happen within the removing the load at the same time, sudden. But in the creep and creep recovery, both will take time. But there is not at all possible to remove all the creep. So there is a certain amount of irreversible creep observed at the at last of the graph. So creep is basically the sustained loading. Sustain means constant amount of load we are putting on the any type of the structural member. So is it clear? Graph is clear? Okay. So next question is, in the context of the fiber, consider the following statement. Statement 1 is, as there is an increase in water and mortar demand due to addition of fibers in the mix, there will be a reduction in coarse aggregate content. Statement 2, the concrete can be produced by simply adding short random fibers to a normal concrete. So what will be the answer? Statement 1 is correct. What about 2? Both are true. Okay. Any other? Okay. Right. Statement 2 is false because we can't simply add the short random fibers into the concrete and we get the same consistency of the concrete or same fresh properties of the concrete. But why we have in the first sentence, what is saying, we are adding the fibers means we have to reduce the coarse aggregate. Why we have to reduce the coarse aggregate? Anyone? No, suppose we design accordingly only. Accordingly we have designed initially only. It's not we are adding like externally. We are initially only designed to add the 2% of the fibers, 2% of the binder. So what will happen? Why we are reducing the coarse aggregate? What happens when coarse aggregate content is there and fibers also there? There is a requirement of water is very high because of the too much agglomeration of the particles will happen, and to maintain the flowability we require a more amount of water. More amount of water means we are reducing the more strength, or we are losing the more strength. So that's why we have we want to achieve some ductility also and some ductile strength also. So that's why we are reducing coarse aggregate content with keeping the fiber or adding the fibers. So that's why we require that one. So next, in the context of the coarse aggregate, statement 1 says that they are all of uniform size, and statement 2 says they are impervious. So, what will be the correct answer? They are in statement 2. Statement 2 is correct, right? and one is false. False. One is true. Okay. And two is both are true. You are saying, right? Okay. Any other? Okay. So right answer is three. Statement one is false and statement one is sorry. Both statements are false. Why? Any other? Can anyone tell me why both the statements are false? Hmm. Okay. And what about two? Impervious. Yeah, it absorbs water because that's why you will heard that most of the times when we are considering the rheological studies, basically, so we are using the aggregates in a surface saturated dry condition. Yeah, so this that is the basic reason we are already kept the coarse aggregate 24 hours in the water. We'll remove, we'll pour, we'll place onto the platform or some not in exactly in the under the sun, but into the normal platform, and we'll remove the running water from that one, and then only we'll use. So that will not absorb any water from the concrete. So it's not exactly impervious. So that's why both the statements are false, and it's not in uniform size because you can see type of coarse aggregates angular are there, rounded, flaky elongated, and elongated. So different types of aggregates are available. So we cannot say it will be the uniform size. But what happens? How will uh, say this type of aggregates are we using? For that purpose, we are using the fineness modulus. So we are using the gradation of concrete, a gradation of aggregate, fine aggregate or coarse aggregate, right? We'll do sieve analysis for that one. We'll find out the fineness modulus. So fineness modulus basically is a number indicating the average particle size based on the grading, and whatever the cumulative percentage grain retain divided by the 100. So we'll get that of fineness modulus. So fineness modulus for the fine aggregate will be the different, and fineness modulus for the coarse aggregate will be different. So based on the sieve sizes we are using, we'll get the average size of the aggregates. And higher fineness modulus means coarser aggregate, while lower fineness indicates finer particles. And code also indicates IS 383. It also indicates that zone according to the sand also. Zone 1, zone 2, zone 3, and zone 4 based on the whatever the fineness modulus you are getting. I hope we already have performed these experiments in the bachelor's. So that's why it's not in uniform size, but for to indicate we are using term as a fineness modulus. Okay. So in the context of aggregates used in concrete, consider the following statements. One, coarse aggregate can be considered as inert fillers. As part of fine aggregates, participate in the hydration reaction and contributes to the compressive strength of the concrete. Statement one is correct and two is false. Okay. Yeah. So all are agree with that answer, right? One is true and two is false. Okay. Right. So coarse aggregate can be considered as inert fillers because it will not uh, participate into the hydration reaction. Whatever the part will not take into part into the hydration reaction, we consider as a inert fillers. It acts as a fillers. Suppose like in the UHPC, we are using the quartz powder externally, that is also as a inert fillers. So in the case of the normal concrete, fine aggregate and coarse aggregate, both are act as a inert fillers. What second statement says? Part of fine aggregate participates in the hydration reaction. We already said it is not a not taking part into the hydration reaction. So statement two is already false. But what happens if you see if you are using the fine aggregate as a river sand, you'll find out some amount of a dust particles in that one, right? So so what will be the test name to find out the dust or silt content of that one? We used to find out that silt content, right? Hmm? I hope you remember we are taking the one beaker, we are pouring to the sand in that one and water, and we'll keep it for some time to identify it. Hmm? No, no, bulk is different. That we used to find out only silt content. What is the amount of dust available in that one? So yeah, like that only. But silt content, silt test only we will call that. And that silt content, if it is that silt content is higher, what happens? Means too much amount of dust is available into the fine aggregate. So what happens to the concrete? Any it weakens the concrete. In what aspect? What happens? Yeah, right. It crack easily because of the higher amount of dust. Maybe you can saw in the normal. Suppose we are normally casting something at home. Also, we are a little bit amount of soil. Also, if you put into the water and will place it somewhere, after some time it will get crack. So higher amount of silt responsible for the crack. So that's why silt content is also major part into the fine river sand. But nowadays river sand has banned, so most of the peoples are using manufacturer sand only. Okay. So the next question is, in the context of water used in mixing concrete, consider the following statements. The added water is consumed entirely in the hydration reaction, and part of water added could be absorbed by the aggregate during or after mixing. What will be the answer? Okay. Anyone else? Okay. Okay. Someone? Both are true. Okay. So answers are differ. So statement one is false and statement two is true because entire water will not consume by the hydration reaction. That's why if you see some normal concrete scanning electron microscopic images, you will see some unhydrated cement paste is available. And in the concreting, some amount of water will get evaporate also because in the lab condition it's different condition. But if you are going to cast into the field, there is a there is always chance to evaporate certain amount of water. And suppose you are using timber scaffolding, sometimes that timber scaffolding also will absorb some amount of water. So that's why statement one is false and two is true because as I said, aggregates will absorb some amount of water. So that's why we are using the aggregates in the saturated surface dry condition. So answer is statement one is false and statement two is true. So in the context of ITZ, the first statement is the porosity in the ITZ is higher than the mortar away from the ITZ. And the properties of the ITZ significantly affects the stress strain behavior of concrete. So what will be the answer? Both are okay. Both the statements are true, and someone is saying one is true. Both are true, right? Okay. The porosity in the IT is higher, right? Because of the higher water to cement ratio. First is correct. The properties of the IT set significantly affect the stress strain behavior. We already saw why it affects, because it affects strength, stress strain, and other durability properties also. So both the statements are true. In the context of the test for determining the workability of concrete, statement 1 says VB test is used to determine the workability of flowing concrete. And statement 2 says the slump flow test involves deformation of fresh concrete as it flows around simulated reinforcement. So, what will be the answer? Statement 1 is false and 2 is true. Okay. Anyone? Any other answer? Both are false. Okay. Okay. Any other? Statement 1 is obviously false because, as we previously also say, baby test is only used for the stiff concrete. We saw that image also. That's why we require to give the vibration to get the flowability of that particular concrete. So one is not at all useful for the workability of the concrete PB test. It is used for the PB test. For workability of flowing concrete, what will you use? Which test I said for flowing concrete? Slump slump flow, not slump cone. Slump flow. Slump flow and slump cone are different tests. Slump cone test is only to measuring the deformation of the cone, deformation of the concrete, and or shearing of the concrete. In the slump flow, you are measuring the flowability up to 500 diameter, 100 diameter. Okay, that's why slump flow test we are using for the flowability, not VB test. And second test, the slump flow test involves deformation of fresh concrete as it flows around the simulated reinforcement. This is also false. We are not like around the simulated around the reinforcement. Why here it's wrong? Anyone? What happens? Yeah, yeah. Tell me. Hmm. Thing is that yeah, right, right. Similar to Yell box test and J ring test, there is a bars available which simulate as a reinforcement. But in the slump flow test, there is no rebars available to get the simulation of the reinforcement. That's why slump flow test deformation of fresh concrete will not use for the simulation of reinforcement around the simulated reinforcement. It is only for the flowability to measure the slump flow. So that's why both the statements are wrong. If second statement only says slump flow test involves deformation of concrete and used for the flowable concrete, it would be correct one. But for the simulated reinforcement, the test will be Yelbock test or J-ring test, which generally use in the self-compacting concrete test. So that's why statement 2 is wrong and 1 is wrong because BB test only used for the stiffened concrete, not for the flowable concrete. Yeah, yeah, please say. Hmm. Which code? Actually, still there is no code available for the UHPC and 3D printing concrete. Although UHPC has almost 2 decades ago has came, but still it's the code is in under process. Uh, maybe I think Malaysia has taken the initiative for that purpose because it has been invented from there itself only. Yeah. Okay. So next question is in the context of the air present in the fresh concrete. First is entrap air is the unintentional air present in the concrete, and second is air entrainment is recommended when concrete is exposed to cyclic freezing and thawing. Both are true. Okay. Anyone? Okay. Okay. So all are agree with both are true then, right? Right. So we already saw entrap air. Entrap word itself says it's unintentionally. We are not intentionally putting. Our air entrainment means we are putting into the air, and it's conditioned when we are putting into the air that cyclic freezing and thawing, which allows this extra space for the frozen water. So that's why both the statements are true, and answer is one. Next question is in the context of the pores and porosity in concrete, consider the following statements. So, statement 1 says in normal concrete, as the porosity decreases, the compressive strength increases. And statement 2 says non interconnected pores in concrete affect the strength but may not affect the permeability of the concrete. So, what will be the answer? Both are true. Okay. Okay. Hmm. Second is correct. And someone is saying second is not correct, right? Okay. Okay. So, some are saying both the statements are true. Some are saying one is true and some two is false, right? Okay. So both the statements are true. Why true? Because pores are less. Normal concrete, as the porosity decreases, the compressive strength ultimately increases because of the less amount of voids and more dense structure. Less amount of voids means more dense structure will get the higher compressive strength. But in the case of the non-interconnected pores, means pores are still available hmm, in concrete, it affects the strength obviously because of the voids, but may not affect the permeability. Why it's not affect the permeability? Because it's not interconnected. So both the statements are true. You can see this image also. This is the isolated pores, which can affect the strength but not the permeability. And these are the interconnected pores, which will affect the permeability. So that's why both the statements are true, and the answer is one. So this type of questions you will get uh, in this assignment. Once you go through that assignment, you'll find out too easy. Once first of all you complete the all the session lectures, and once you complete that lectures, you'll go through the assignment. You solve that assignments. You can complete or you can answer that assignments until the deadline so many times. You can submit it multiple times also. So whatever the last submitted assignments will consider as the final answers. And whatever the doubts you will have through the lectures or maybe through the assignments, you can ask in the next live session, or whatever the doubts you have now also you can ask me. I will try to answer that one. So I hope you got some idea how will be the question into that assignment, and how to answer that one. So anyone? Yes, yes, can you please repeat? Yeah, yeah, weekly once on every Saturday 6 to 8. It's No, it's not possible. Actually, they have decided very prior, before starting the session itself. It has been decided, so it will be very difficult to change. But there will be a live recording also. You can get it will I will upload this on the YouTube, so you will get that through that link also. You can access on the YouTube also. Yeah, that's what. So that's why it's like a dual and means interactive session will help to get the more idea. Yeah. So that's why. But time is now very difficult to change. It's not in my hand also. Okay. So anyone have any doubt? Please let me know. You will give whatever the recap I have given in this lecture also. You will get more idea once you go through the details through the lectures. So professor has given multiple examples and detailed explanation also. You can download their transcripts on the website also. So detail whatever he will say that exactly written in also the transcripts. So that will also useful for you. This one. Yeah, this one you will get it through the link that NPTEL will share all the links with you. Hmm. So I will upload onto their website. They will share all with you. So this one also and live this session is also recorded. So you'll get that recording also available on the YouTube also. So you can ask me question now also, or you if you want you can in the next session also you can ask me questions about the week one and week two also. So next session will be on the Saturday, next Saturday, 6 to 8, and that will consider that will have some recap of the week two lectures and some questions related to the week two lectures. So this session has only consider the questions related to the week one only. So so whenever you will go to the lectures, you will find out already this type of questions professor has covered in that lectures. These are the previous year questions actually. So no one has any doubt. Okay. Then we'll conclude this session. Okay. Okay. Thank you. Good night. Good night.